Let's lay out this pattern on a different table. For y equals x squared, which is our simplest quadratic function, we get the following relationship between our inputs and our outputs. Just multiply your input times itself and you'll get your output. Let's look at a different quadratic function. Now we have y equals 2x squared. It's still a quadratic function because it still has an x squared term. Now our input is being multiplied by itself and then being multiplied by 2. If you remember, the order of operations tells us that exponents should be done before multiplication. Another way to write 2x squared is 2 times x times x. Let's plug in some inputs and find some outputs. First, let's plug in 0 for x. So our equation becomes y equals 2 times 0 squared. 0 times itself is just 0, and 2 times 0 is 0. So when x is 0, y is 0. Let's try 1. If we plug in 1 for x, we get y equals 2 times 1 squared. We first square the 1 because exponents are stronger than multiplication, then we multiply by 2. 1 squared is 1, and then 2 times 1 is 2. So when x equals 1, y equals 2. Let's try 3. After we try 2. 2 squared is 4, and 2 times 4 equals 8. So when x is 2, y will be 8. Let's try plugging in 3, 4, -1, and -2 for x. 3 squared is 9, and 2 times 9 is 18. 4 squared is 16, and 2 times 16 is 32. -1 squared is +1, and 2 times 1 is 2, and -2 squared is 4, and 4 times 2 is 8. So if we put all of these input-output pairs into a table, 0 gave us 0, 1 gave us 2, 2 gave us 8, 3 gave us 18, 4 gave us 32, -1 also gave us 2, and -2 also gave us 8. Just like on the top table, 1 and -1, 2 and -2, 3 and -3 give us the same numbers on both sides, giving us a symmetrical pattern. We see the same thing here. 0 is 0, and 1 and -1 are matching. They mirror each other. If the pattern continues, we can fill in these two values, looking at these two values. A very important thing to notice is that y equals x squared and y equals 2x squared have a relationship. This one is twice as big as this one. We can see that in the outputs on our tables. 1 has doubled to 2, 4 has doubled to 8, 9 has doubled to 18, 16 has doubled to 32, same on the other side. What output should go with 5? Well, it should just be the double of 25. If we plugged in a 5 here, we get 5 squared is 25 times 2 is 50, and it will be mirrored on the other side. So it is very important to understand this pattern, squaring your input, because the rest of the quadratic functions will be based off of this pattern. Like this one is the same pattern, just doubled.